Today we are back again. Today we'll be looking at the phases of data analytics. The phases or the phases and phases we see in data analysis, or we call it the process or processes of data analysis. So today data analysis typically involves several phases or phases that help organize and guide the process of extracting insight from data. And today we'll be looking at the phases. Let's look at the phases and then together with the explanation. And number one is data collection. The first phase is collecting relevant data from various sources. This can include data from database, spreadsheets, surveys, web scraping, and sensors, and or data from other generating mechanisms. It is important here to ensure that data quality. It is here to ensure that data quality during these phases by checking for missing values, outliers, and inconsistency. Being meticulous and then paying attention to details. Data should be clean and prepared for analysis. In this stage, it's more of gathering information, from raw data, and then putting it together. Then another phase is number two is data cleaning and pre-processing. In this phase, data collected is cleaned and transformed into a suitable format for analysis. This involves handling missing data, dealing with outliers, and then standardizing or normalizing variables. Here, data pre-processing also includes tasks like encoding categorical variables, feature scaling, and then denominational and dimensionality reduction to improve the quality of data. Another stage of phases of data analysis is exploratory data analysis, EDA. Exploratory data analysis. This involves exploring the data visually and statistically to gain a preliminary understanding of its characteristics. It includes creating summary statistics, histogram, scatter plots, and other visualization. So EDA helps identify patterns, relationships, and the potential insight in the data, which can guide further analysis. Number 4 stage is data modeling and analysis. In this phase, various statistical and machine learning techniques are applied to pre-process data, to uncover patterns, make prediction, answer specific questions, and so on and so forth. So, depending on the nature of the analysis, this phase may involve regression analysis, classification, clustering, time series forecasting, or other modeling techniques. So, the next one is interpretation and inference. Here, once the model are built or analysis is conducted, the result needs to be interpreted into the context of the problem and the set objective. This phase involves making sense of findings and drawing meaningful conclusions. The statistical test and hypothesis test may be used to support the conclusion and validate the results. The next stage is visualization and reporting. Data analysis results are often communicated through data visualization, reports, or presentation. Effective visualization helps convey insight to stakeholders in a clear and understandable manner. Reporting should include key findings, visual representations of data, and actionable recommendations for decision makers. The next one, number 7, is validation and integration, or let's call it validation. Data validation. It is essential to validate the result and analysis method to ensure their accuracy and reliability. This may involve cross-validation, sensitivity analysis, and or comparing different models. Depending on the validation outcome, the analyst may need to iterate through previous phases, adjusting data collection, pre-processing, or modeling as necessary as the case may be. Then another one, we have the last and the least, deployment. Well, this one is not compulsory if applicable in the project being carried out. In some cases, the result of data analysis may be deployed into production systems such as recommendation engines, fraud detection system, or automated decision-making process. Deployment involves integrating the analysis into operational workflow and monitoring its performance over time. So these are the phases. These phases provide a structured approach to data analysis, guiding the analyst to build or guiding the analyst through the process of turning raw material into actionable insight. It is important to know that the data analysis is often an iterative process. So with the analysis revisiting earlier phases as needed to redefine their approach and achieve meaningful results. So that is it for today, and we hope you enjoyed the lesson, and we would also encourage you to subscribe for more updates. Thank you.